This first ratio question is on the easier side of the spectrum. Most students I show it to get it right on the first try, but I want to say up front that if you were thinking of skipping this question and moving on to the harder ones, I wouldn't, because this question will lay the foundation for every question we do after this. Remember what I said in the intro. The thing that I like about ratio questions is that they are all the same. If you have a framework for doing them, the hard ratio questions are not that much different than the easy ones. And this is the video where we will go over that framework. I also like this question because it highlights an important point about how to study for the GMAT. In other words, even though most students I show this to, they get it right, and they tell me that the answer is D, which it is, I then ask them, why is that? Teach it to me. And they say, well, what do you mean? It just is. In other words, they read the question and they can just see it. They can see it in their brain that the answer is a D, and most people are satisfied with simply getting the answer right. But that was not the case for me when I was studying for the GMAT, because having to rely on my brain seeing the right answer makes me nervous, because I know that my brain is not that big. I am not that great at math. So as the questions get more complicated, there's a good chance that the answer won't just magically pop into my brain. So now what I am good at is logic. So if instead of having to rely on my brain visualizing the answer, I can then prove it on paper instead, well, now I have an approach to ratio questions that is A, intuitive, and B, I can apply to other more difficult ratio questions. And that is the point of this video here. So the question says, if a pond contains only ducks and goldfish, what % of the animals in the pond are goldfish? So pretty straightforward. There is not much we can do with the prompt, but even in questions where it might seem like we can't extract a lot of information from the prompt, usually there is more than you might think. So for a question like this, where it says it doesn't seem to be giving you much information. We got ducks, goldfish, nothing else in our pond. Then it says what % of the animals are goldfish. So one thing, whenever I see a word problem that is asking me for a % or a fraction or a ratio, I know I can always express that as just something over something else. And if I can write out in words what those things are, then I know exactly what I am looking for. So in this case, they're asking for what % of the animals in the pond are goldfish. So they are asking for our goldfish over our total animals. And then if you see that, oh, I only have ducks and goldfish in my pond, well, that total really just means ducks plus goldfish. So I can write this like that. While this may seem like overkill, by this point, most people have solved the question. The point is not for this question, it's for the more complicated ones. So once I get to here, this is actually pretty helpful, because think about what this is telling you. You might want to go one step further and say, okay, so this is really because it is a data sufficiency question. I just need to know the number of goldfish that I have in my pond and the number of ducks that I have in my pond. But that is actually not true, because remember, what data sufficiency is asking you is what is the minimum amount of information needed to answer a question. So in this case, once I write it out in words, I can now assign variables. So I'll say G and D. If I can find that my ducks are, say, 3 times my goldfish. So now I would have goldfish over goldfish plus 3 times my goldfish, because those are my ducks, which would be G over 4G. My G's cancel, and I get my answer of 1/4. In other words, I don't know the number of goldfish I have. I don't know the number of ducks that I have. But if I can get one in terms of the other, that is all I need to find the % of animals that are goldfish. And this is true for any sort of word problem where they are asking you for a fraction or a percent with two variables. It's not necessarily the case that you need to find both of those. If you can just get one in terms of the other, if you can get a proportion relating the two, that is enough to have one of those variables cancel out. So in terms of rephrasing the question, this is really as far as you want to go. Statement 1. The ratio of ducks to goldfish in the pond is 3 to 5. So now we start getting into the ratio part of this question. So ratios are commonly expressed with this colon notation, which I think is helpful when I am setting up my ratios, when I am organizing my ratios. And then when I am doing arithmetic, I usually will use fractions, so 3 over 5. But what I don't like necessarily, so I like this colon notation, but I don't necessarily like writing them like they have it, like 3 to 5, because this is not super helpful, because this does not mean necessarily that I have 3 ducks and I have 5 goldfish. It could be It could be 3 to 5, but it could also be 6 to 10, or it could be 9 to 15, or it can be 30 to 50. These are all possible. And so what I like to do is I always want to express my ratios, the number that I have here, it's as the actual number of whatever that thing is. And so in this case, there are multiple possibilities for how many ducks. There are infinite possibilities for how many ducks and how many goldfish I can have, but I still want an expression that accounts for all of those possibilities. And so instead of saying 3 to 5, I might say, well, I have 3x goldfish, and then I have 3x ducks and 5x goldfish, where x is just some multiplier. So that is really the thing that is changing here. So in this case, x is 1. In this case, x is 2. In this case, x is 3. In this case, x is 10. And the reason I like this notation is because the way I had it before, if I just said 3 to 5, I cannot then take that number and plug it in to an equation of some sort. If they were to say you then added 2 ducks to the pond, I cannot say, okay, well, I had 3 before, and then I added 2, because it is not true necessarily that I had 3 ducks before. But what I can do by writing it like this, now I can say, if they say I add 2 ducks, well, I can say, okay, I had 3x before, now I have 3x plus 2 ducks. And remember, it's still possible that you actually do have 3 ducks, because x could be equal to 1. But here, it is not necessarily true. And so I'm taking that into account. This also highlights another thing about ratios that I think sometimes people aren't aware of. Because they are used to seeing ratios expressed like this, people tend to think that, oh, it is the 3 and the 5 that make this ratio. But that is not true. Sometimes when I ask students to set this up, or I ask them to set any ratio up for the first time, they will say something like, oh, this is 3D to 5G. Now, think about what you are saying, though, in this case. So if you're saying D and G are multipliers, but they are not necessarily the same multiplier, now you are just saying your ducks are some random multiple of 3. Your goldfish are some random multiple of 5. There is absolutely no connection whatsoever between your ducks and your goldfish. So what makes these two things in the same ratio is not the coefficient. It is the fact that they have the same multiplier. So if you had a different pond, they said, that also had ducks and goldfish in a ratio of 3 to 5. Well, you would have to write that as 3y to 5y, because that is a new ratio. And what connects that new ratio is the fact that your ducks and your goldfish in your new pond have the same multiplier, but it's not necessarily the same multiplier as you have in this pond. So the fact that your ducks and your goldfish have the same multiplier, they have the same x, that is what is saying makes it saying for every 3 ducks, you have 5 goldfish. And so the last thing I like to do is I also like to add a column for the total, which does not always come into play, but oftentimes does. So, like I said, this might seem like overkill for an easy question like this, but as you will see, we are going to do the same thing on pretty much every question. So now in terms of answering the question, I am looking for goldfish over my goldfish plus ducks. So that is just 3x over, 5x over 3x plus 5x, 5/8. So this is sufficient. And then the ratio of goldfish to the total number of animals is 5 to 8. Well, that's literally just answering my question. 5 to 8. Ratio means the same thing as percentage. So